Hello everyone, my name is Benimeni and today I'm going to present you Kmeans. First I'm going to show you the use cases of this algorithm, then I'm going to follow up with some Pseudo Code and natural Python implementation, and then I'll show you the pros and cons of this algorithm. So, Kmeans is an unsupervised machine learning algorithm which is mainly used for clustering. If we have a lot of data points, which are unlabeled, for example like this, we want to group them into clusters so that every point within a cluster shares about the same features, or that the points are quite similar. For example, like this. So imagine we are in a big online shop and have many different clients and we sell clothes and tech. Then we collect the data about our clients, so how many tech items they buy and how many clothes they buy. Then what we can do, we can decide for each client what advertisement to show them. To do so, we want to group all the clients that share the feature of buying a lot of clothes into one cluster. So we run the Kmeans algorithm, get our different clusters, and then what we can do is we can target each individual cluster with a certain type of advertisement. So we have the unlabeled data points would actually result in clusters of data points, and then these clusters share some kind of the same features. So this is Kmeans. It's actually quite easy to understand. As you can see, it actually only incorporates a few lines of code, which also makes it quite easy to implement. I'm going to show you my implementation in Python in a few seconds. So Kmeans, we only need to pass it two inputs, which is first the data, which makes sense because we want to train on that data, or learn on that data, and k, which is the number of clusters we want to divide the data into, which for the previous example that I showed you, it's 3. So what we first want to do is we want to select k centroids for the different clusters. So one centroid for each cluster. Centroid sounds complicated, it's actually not. It basically just means the average value of all the data points within a cluster. Since we don't have any data points in any cluster at the beginning of the algorithm, what we just do is we randomly select k data points. These will then represent the mean for each cluster at the beginning. So what we want to do is we want to assign each data point, which is line number 3, to the cluster where the centroid is the closest. That means basically, for example, you can take the Euclidean distance as a distance measure. The Euclidean distance, you know it, it's x1 minus x2 squared plus y1 minus y2 squared, the whole thing in the square root. So it's just the distance of the line between 2 points. Then what you want to do, after having assigned all the data points to a cluster, you want to recalculate the means of the cluster. So basically, you adjust the mean to the mean for this loop. I'm going to show you a more visual representation in a minute. And what you want to do is you want to iterate over both of the steps that I just explained to you until no more data point actually changes the cluster. So until no centroid actually changes anymore, that means we have assigned each data point to the cluster it will finally belong to. By doing this all over again, we will see in a visual representation in a few seconds that we shift the means and also the data points to the correct cluster they will belong in the end. So this is my custom implementation of Kmeans in Python. I'll go over it in a few seconds, but first I want to show you the visual representation of the Kmeans algorithm. So I'm just going to go ahead and run it. So this first image is the unlabeled dataset just plotted. So nothing special, the same thing as I showed you before. Then the first step of the algorithm is assigning the centroids. So here you can see the black centroid here, the black centroid here, and here. So we just randomly selected those in the dataset. Then we assign each data point to the closest centroid. So you knew one centroid was here, one was here, and you will get like quite a nice line. So all the blue ones belong to, like, are closest to this centroid, all the red ones were closest to this centroid, and all the green ones were closest to the other centroid. Now, after recalculating the average of the clusters, we reassign the centroids. So you can already see a clear shift for the green centroid, which was previously here. Now it's shifted to the middle of both blobs. So then, after reassigning all the data points again, we can already see that there's a little bit more blue data points and a little bit less green data points and a little bit more red data points. After doing the same thing again, we can see again a slight shift here, and also for the green data point. Running it again. So you can already see there's already many more red data points, and this blob actually starts to become completely blue, and this one starts to become red. So let's do it again. We can see again here the shifts of the different centroids, so the average values. Let's run it a few times, a few loops. And here you can already see that the centroids have actually been shifted to the middle point of the different blobs. So after assigning the last step, you can see that this whole blob has been colored in red, this whole blob has been colored in green, and this whole blob has been colored in blue. Which is then also the final cluster assignment for each individual data points. From the example before, you could imagine this group of people to be the groups that we want to target with advertisement about clothes, this for advertisement about tech, and maybe these are just some mixed up clients that buy a little bit of both items. So now I'm going to go ahead and tell you about the code. Okay, so for Kmeans, what we first want to do is, as said, we want to assign the centroids to random elements in the dataset. So what I did, I just selected some random rows from the dataset and set the data of those rows to be the centroids. Then I first assigned all the data points to a cluster with the label -1, so that they are not assigned yet. Then I also calculate how many data points we have for each cluster in each iteration, which we will need to calculate the mean. Then for each data point, I calculate the distance. Here I just use the Euclidean distance, which is the square root of the sum of both powers of the differences of the values of x1 and x2 and so on. I save the old assignment in order to compare if at least one data point changed cluster, so we have not converged yet. So this will check if there has been any convergence. Then I'm going to assign the data point to the cluster where the distance is the lowest. So this is done by the argmin function, which will give us the centroid with the lowest distance to the data point. Then I check if any item or any data point has changed cluster in this iteration. If none of the data points have actually changed cluster, then no change will stay to true and we will exit the loop in the next iteration. What I then do, as said, is we just calculate the new cluster means, which is just summing up the values for all the data points and then dividing by the elements per cluster. So then just dividing by the number of data points within the cluster. And we loop over this until we converge, so until we have no change detected anymore, and then we just return the assignment. You can also do predictions for this K-mean algorithm, which would basically just mean storing the centroids and then assigning a new data point that we've not seen before to, again, the centroid with the closest distance. So this algorithm is actually quite efficient in terms of memory when you want to deploy the actual model. That actually sums it up about the Kmeans algorithm. It's quite easy, not too difficult. If you have any questions, just leave them in the comments. And also, if you have any suggestions about how I should explain the algorithms, or if you like it, it would be nice if you can give me some feedback in the comments. So Kmeans does have quite a lot of cons, but also some pros. So for the pros, it is an easy and simple algorithm which is easy to implement and also easy to understand. There are also many different versions of it, for example the mini-batch K-means, which does not use the whole dataset, but mini-batches of data to train the algorithm. And there are also some different initialization strategies which do not randomly initialize K-means. If you want to have a further look into that, for example, there's an algorithm called Kmeans++. It also scales quite well to many different data points, so if your dataset gets quite large, it can still handle that. Sometimes you need to do some approximations, but that's not important for now. Now to the cons. So the first con is that it is quite sensitive to the initialization of the centroids. If you initialize your centroids poorly, you'll also get poor results. For example, if you use 3 times the same centroid, you will only basically get one blob for the whole dataset. It can also not detect noise or outliers. For example, if we have some faulty measurement, and this would lie far outwards of any cluster, it would still be assigned to a cluster and not be detected as faulty measurements, which we don't want, because this can actually get you quite poor results if the dataset is very noisy. It also struggles with different shape of clusters. For example, for concave clusters, you will see that the wheel clusters will actually be split apart. This also happens for clusters with uneven variances. For example, if the variance in the x direction differs from the variance in the y direction, the real clusters, so the real blobs of data, will actually be split into 2 different clusters. One last big thing that is actually quite problematic is that you actually have to know the number of clusters beforehand. As for the example before, if you set k to 2, so 2 clusters, but you actually have 3 blobs, 2 blobs will actually be colored in the same color. This can, for example, be seen here. For the upper left picture, you can see that the 2 blobs have the same color because we set k equal to 2. Then for anisotropically distributed blobs, we will also see that the different blobs will be split actually into 2 different kinds of clusters, which is false. We have the same thing going on for uneven variance between blobs. So 2 blobs are quite compact, and the blob in the middle is actually spreading out quite far away. Then some of the points from the middle blob will actually be assigned to the other clusters. Or we can see that, for example, K-means can also handle blobs of different sizes quite well, which is on the lower right picture. So that's about it for K-means. If you liked how I explained the video, if you have some things that I should improve, just tell me in the comments. Otherwise, I would appreciate if you liked the video and subscribe. Thank you very much.